Okay. Tonight I'm going to show you a kind of geeky practical application of virtual worlds. It's a software debugging tool called VR Malloc. Text kind of tools to do the same sort of things are available, but I'm going to show how using a form of virtual reality can convey more information about what the program is doing and convey it better. If you add a third dimension, then you increase the information density by an order of magnitude or more. If you transform this to an animated virtual world that you can explore, you can increase this information density yet again. Now, there's a reason for this. It's because our brains have evolved specialized circuitry for dealing with 3D, for recognizing patterns, breaks in patterns, motion and depth. We have to be taught to absorb information in the form of text, and it's a lot of work. When you're reading, you're getting a few hundred bits per second. When you watch TV, it's millions of bits per second of some kind or other. So here's the geeky part. Programs usually need to borrow memory from the operating system, play with it, and give it back later. If you're doing a lot of this, it's really easy to screw up. And these can be some of the tough problems to catch because the consequences can follow the causes by seconds or minutes. Now, a second is forever in machine terms, and the trail can get pretty cold at 2 billion instructions per second. The name of the game in debugging programs is to learn as much as you can, as fast as you can about what your program is doing. Unfortunately, software tools to do this have lagged far behind the hardware tools. The hardware tools are primarily visual, oscilloscopes, logic analyzers. Software tools are still using text. VR Malloc is a software debugging tool that shows you how your program is using dynamically allocated memory. It does this by looking into it, figuring out some of its structure, figuring out where it's doing these memory operations, and then here's the interesting part, it automatically generates a symbolic world to represent this stuff in a way that's more accessible, shall we say. So I'm going to start this thing out. Now, it's generated a symbolic world to represent the program that we're going to be watching. Let's see, what are we looking at here? This is awkward. These book-looking things represent files, places where we keep the program code in visible form. And these are functions in that file. Functions are chunks of code that have some specific job to do. And these objects represent places in that function's code where some memory operation is done. Allocating memory, freeing memory, changing its size, things like that. The type of operation, different operations, different appearances. Now I'm going to start up the program that we're going to be watching here, and it will begin by allocating 1,000 pieces of memory. Zip. Now, can you see where in the program this memory was allocated from? Can you see which pieces of memory are the biggest? Of course you can. It's obvious. I don't have to explain these things. Now I'm going to release this program to go on about its business, calling functions in various files and doing lots of memory stuff. Now I know who the programmers are in the crowd. It's hard to say exactly what unless you have a particular case in hand, but you can learn a lot just by the way things are behaving here, just by the way your program is dealing with memory, allocating a bunch of chunks at once here, getting rid of a bunch, doing a bunch of random ones, things like that, changing the size of them. Now, let's see. Sure. So, watching this thing up here, watching the parts of the program up here instead of the memory, which I should have been watching, you can see where the program is using, where the program is spending most of its time and when. You can get a feel for how execution is moving around in the program, what places are busiest, the hotspots doing a lot of memory operations, what places are holding most memory. Normally, to find this stuff out, we would usually have to wade through hundreds or thousands of lines of program listings saying, and stuff like, now I went here, now I went there, now I did this thing, now I allocated this memory, blah, blah. Very tedious, no fun. If we wanted to find out more about something we saw there, we would have to type in some arcane commands, maybe a lot of them. Or maybe we'd have to type some more code into our program and rebuild it and rerun it and look at all that listings again. This is a typical software debugging cycle. We may have to do this a bunch of times just to find one bug. In VR Malloc, if you want to know more about a thing, you just fly over and have a look. Here's a busy place. We can see that this is a place where memory gets allocated. We can see a lot of statistics about it. We can see exactly where to go in the program to look for the code where this happens. It's line 45, function Phoebe, and file janus.c. Looking further down, we can see that of all the ways this could have gone wrong, exactly 0 of them have happened so far. We can look up a level at the function level and see a summary of all that stuff over all the places in that function that memory operations have taken place. Now it's time for the program to clean house and give back all the memory that it has borrowed. all the memory that it has borrowed. Looks like it lost track of a few pieces. What can we find out about this? Are they all the same size? No. Were they all made at the same time in a group? No. Were they all made from the same place in the program? Bingo. Let's go interrogate the guilty party. Now we know where to go to look for the start of the trail of finding this bug. It will be line 471, function down, and file titan.c. These are all moons of Saturn, by the way. Now, this is a class of bug called a memory leak. They're notorious. When they crop up, they can take a long time to find, hours, even days. No kidding, I've spent days chasing some of these. And the first thing that you need to find out when you're doing this is which pieces of memory actually went missing, because usually you just know, oh, the totals don't add up, and where they came from in the program. Like I said, this can take hours or days just to find out that much. This way is much quicker. Now, one of the big challenges in making this tool was that bit about automatically generating a symbolic world to represent something that isn't at all visual. Not only that, but to do it in at such a high level of abstraction that most of the tool's code has no idea what it's dealing with, whether it's memory allocation or nuclear reactor operation or air traffic control or network monitoring. All these are things that could benefit greatly from using VR as a user interface. Also, I have this plan that I'm going to make. This is going to be, the first of a series of tools that reuse much of the same code and take a similar approach to representing complex structures and activities. I might as well say it now. This is not full-on real virtual reality. Did I say that? You don't have to use gloves or goggles to use this tool. That's because the objective was to make a tool that software engineers could use in the workplace as it is today. I think this is going to change, though, as the nature of software changes and as the way that we build it continues to evolve. In the future, we may be snapping pieces of it together like Lego blocks. I'd like that a lot because instead of typing in text, well, you probably already gathered that I hate typing. The evolution of high-performance graphics, hardware, and software has been largely driven by the gaming world. If there's one thing that I want you to remember about this, or take away from this, it's that virtual reality is not just games and entertainment. It also, more and more, will include practical applications like this. Thus endeth the tale. Thank you. Now, how much time do I have? How much time? 30 minutes? I don't have a clock. Yeah, all right, I'll do that. So now for something completely different. I'm going to talk about the intersection of virtual currencies and virtual worlds. Yes, there is such an intersection. Those of you who are in the gaming world already probably know what I'm talking about. For the rest of you, this. Games are very sophisticated these days. You can have a body, you can walk around, you can talk to people, you can carry things, you can have property, weapons, armor, tools, and gold. Some of these things you can make from available materials lying around. Some of them you find them lying around in the course of an adventure. You can trade with another player for them, or you can just kill him and take his stuff. The gamers are a bloodthirsty bunch, and it's a jungle in there. So, we have people, places, property, and transactions. This is an economy. And when you have an economy, you need a medium of exchange, a store of value, a unit of account. This is the definition of money. Now, a lot of you are probably thinking, so what? It's just game money. It's imaginary. It's virtual. It doesn't matter. You can't buy groceries with it, can you? Well, it turns out you can. Gamers attach a high value to game assets. And, if for no other reason, they have to work long and hard to get them, so they have a labor value. This is how real value gets attached to any fiat currency, dollars or whatever. Now, some of these guys are willing to pay real dollars for these game assets. So, of course, websites pop up where you can do just that. You can go there, give them dollars, and buy a +5 sword of mighty smiting in World of Warlord or something. And it works the other way around, too. You can sell your game assets at this site and take away dollars. Use them to buy groceries. And Bob's your uncle. You can buy groceries with the virtual currency. Just a little currency exchange transaction. So there is an intersection, a coupling between virtual currencies, even game currencies, and the real economy. Now, Sherman, climb into the Wayback Machine and set the dial for 1990. Zip! Here we are in 1990, and we don't have a clue what's about to happen. The internet is all text. We get around with Telnet, Gopher, Archie. Who remembers those things? Not many. We're fossils. It's an information desert there. There are just a few islands of information. They're small, they're shallow. We don't have a clue. Hello. Oh. We don't have a clue that someone is about to invent a thing called Mosaic, the first browser, and HTML, and that it's going to change everything. Back to 2015. Zip. And it has changed everything. It's transformed society. It's now a vast ocean of information. We can get lost in it. Drinking through a fire hose, I think, is the expression. There are things that we can do on the web that and do them much more conveniently and easier than we can do in the real world. So we go there to do them. Shopping, banking, meeting, organizing, all that stuff. And there are things that we can do on the web that we never dreamed of doing in the real world, but now we spend a lot of time there doing it. So, do you think that it's going to stop here? Is this it? Will we just sit around and improve it and tweak it? It's the web. It's good enough. Not going to happen. I can't really know what the next thing is going to be, but you can bet that it will be as transformational as the first one that we lived through. So since we've already had one experience kind of like this, we can use the tool of analogy, a powerful tool but a slippery one. So ARPANET is to the web as the web is to what? Well, let's see. Instead of websites, we have virtual worlds. Anybody can make one using commonly available tools. You can own one. You can use it for anything you like. You will find things to do with it. It will be entertaining or profitable or just plain wacky or things that we can't imagine now. So instead of links, we have portals, doorways between virtual worlds. Walk your avatar through the portal, and you're in someone else's world. It's just like clicking on a link now, go to a different web page. Instead of browsers, this is a tough one. Let's call it, we have a browser. Okay? Games have these clients that you run that are specific to one game, and they're how you drive your avatar around, how you control it, and they're how you get to see what's in the game. But it's specific to one virtual world. In the next world, this browser thing, we will have standards. There will be standards for how your avatar is controlled wherever you go. There will be standards for how websites are represented and how the world looks to you, how it is manifested to you. And speaking of standards, when we built the web, there are some things that we overlooked to our regret. We probably won't make that mistake again, I hope. In the next one, there will be some native utilities, infrastructures for some of the things that we forgot before. Infrastructure for value, for identity, for reputation and trust. Probably other things that I don't see because I have this narrow kind of economics viewpoint. There will be profitable services growing up around to exploit these things. These things and all this other stuff I've been talking about are a kind of glue, a glue that holds all these virtual worlds together. And the glue in the virtual worlds are this metaverse thing. You knew I was going to say that sooner or later. Public speaking terrifies me. Someone bring me my brown pants. Okay, let's zero in on one of those utility things, one that's dear to my heart. Identity. I could talk for an hour about just this. What is identity? It is a unique thing with 0 or more links to other identities, places, things, events. If in fact there are 0 links, it's an anonymous identity. And we know about that from the web, good stuff and bad stuff. Now, this has, we have infrastructure for trust and value. By value, I mean like, money or anything else that we use as a currency. There is some tension between anonymity and trust. In fact, you probably think that they're mutually exclusive. There's some reason to believe that. That turns out not to be the case. There are ways that anonymous actors can have trusted transactions in a virtual world. It's kind of tricky, but cool. And I'm going to give a couple of examples of this, but first I have to define an essential component necessary for this called the digital coin. The formal name for this is a digital bearer certificate, or a DBC, and they've been around for a while. What it is a container, a secure or trusted container for something, anything. You can put anything in it. Usually it contains some certified fact. I have a BA in computer science or whatever, or some contract or promise, like, this is a gold gram coin. If you give it back to the issuer, he will give you a piece of gold in the real world. A promise of something. So, our first example. I have a $10,000 coin, and I want to swap it with your 1 kilo gold coin. We're both anonymous. This is a virtual world. One of us could we put these things on the counter, and we're supposed to pick up the other one. But what if we snatch both of them off the counter, and one of us snatches them and runs? What's to keep us from doing that? Well, both of these assets are what in the currency world we call frangible, meaning we can divide them into smaller pieces that are indistinguishable from each other. So we do. And I put down a $10 coin. He puts down a 1 gram coin. We do that swap. Seem to go all right. So we do this 1,000 times. Of course, not manually. We can automate this. And a fraction of a second later, we have done a $10,000 transaction. But at no time a $10,000 transaction. But at no time was there more than $10 at risk. How did we do this? We distributed the risk over time. And this is one of the classical is the wrong word because it's not that well known, but one of the ways I know of to have an anonymous transaction. Now let's look at the tougher case. I have a Ming vase coin. Never mind how it came to be a Ming vase coin. I'll get to that in a minute. The point is, I'm at this antique store in a virtual mall, and I want to sell them my Ming vase coin. But the vase is not frangible. We can't break it up into pieces. So the coin is not frangible either. How do we do this? We go to Wally's escrow world. Wally will make us a thing we might call an escrow room. It's a virtual place that has an interesting property. You can only enter it with 1 coin. You can only leave it with 1 coin. Get the picture? There's no way one of us can snatch both coins and run. If you log out, both of the coins will fall on the table. Oops. It just doesn't work. How can you make it do that? Well, he who owns the world makes the rules. It's, the mechanics of this are a little complicated in crypto terms, but not all that complicated. I won't get into it. Trust me, it can be done. How did we know that we could trust Wally? Well, there are reputation servers in this world. In the mall, there's this big board with trust ratings for all the shops in it, maintained by reputation servers in the metaverse, like the credit rating agencies in the physical world. And Wally has probably deposited a $50,000 bond with some metaverse bond agency. You see, we have a financial infrastructure here. That's how we make business work in this potentially anonymous world. So, anonymous. Can't criminals use anonymous to protect themselves? Yeah, that's the downside. Of course, they use cash too, and so do we. We're the good guys. It has its uses. So there's an upside to anonymous. It can also protect people who want more privacy. Most people don't seem to be real concerned about that these days. You gals don't seem to care that there's a database somewhere that says you bought a B cup at Nordstrom's last week. However, talk to the Falun Gong in China. For them, privacy is a life and death matter. It matters. And the anonymity can also protect people who want more freedom, because in the metaverse, nothing happens that isn't consensual or voluntary. There's no violence or coercion there. Nobody can break your arm, beat you up, put you in a cage, kill you, take your stuff. Now, some of you may not like this, or you might be against it, or you don't want to do it. That's your choice. In the metaverse, we will have a choice. And choice is a beautiful thing. Now, all this may seem fantastic to you in the sense of something that can't really happen. What if I told you that I had lived and worked in an environment like this for a while? I did. It wasn't a virtual world in the sense that we've been talking about here. It predates that stuff. It's economic. It was an economy that grew up around things called digital gold currencies, online virtual currencies that are redeemable back and forth for gold and dollars. I had a job working with other anonymous people, building some of the infrastructure for this place. The bond agencies, the escrow agencies, the currency exchanges, the stock markets. Yes, there was an anonymous stock market. How about that? In fact, I operated a small escrow business there. My salary was $0.25 kilos of gold a month, payable in e-gold, one of those currencies, or 1MDC, a derivative currency of e-gold. I could take my gold to an out exchanger, and he would wire dollars to my bank. I could use that to pay the mortgage because they don't take e-gold. I also had this thing that was uber cool. It was a debit card, but it didn't have my name on it. It just had more numbers. I didn't have to show any ID for it, but it cost me a pretty penny. Now, this thing was linked to my gold account, but I could take it to the grocery store and it would pay off in dollars. This is just like when you go to Europe with your dollar Visa card and it pays them in euros. That's just the way these cards work. So, using my gold, I could buy stuff at the grocery store. I could use it at the gas station, at the liquor store, the hardware store, the ATM. I could get dollars out of the ATM with this. My anonymous gold account and these also anonymous dollars. Just wow. How cool was that? I was living and working off the grid. No one could see where I went, how I spent my money. Lest you think that I'm all about the money. If you surveil and control a man, you surveil and control a man's wallet, you surveil and control the man. So, therefore, if your money is private, then a whole lot of the rest of your life is private. I can't begin to tell you how liberating this was. This was really cool, as long as it lasted. It didn't last long. After 6 months or so, the government came down on it like a ton of bricks. They don't like competition, and they use their money. Never mind, I'm getting too political. So, I lived off the grid. It was great. Maybe you think this is wrong. I'm no criminal. I have ethics. Do no harm. Mind your own business. Take no crap. There are 3 rules of golden living. I wish everybody lived that way. You don't have to agree with me on that. You don't have to live the same way. But you have no business telling me how to live. That's why I like the metaverse. They can't tell you how to live there. You have a choice, and choice is a beautiful thing. There are 3 things that I want you to remember from all of this. One is that there will be a next thing after the web. It will have something to do with virtual worlds. And the second thing is anonymity is not evil. It has an upside and a downside, but it has some personal and social benefits. Furthermore, it is possible for commerce and privacy to coexist. They aren't mutually exclusive. And finally, all that glue stuff I was talking about, somebody is going to have to make all that stuff, and they are going to make a lot of money. Thus endeth the other tale. Thank you.